Okay, really quick, I'm just going to go through the examples given in your PowerPoint, just give a more in-depth explanation, visual overview of what's going on. So I think in the first example they give you, after you balance equations, they give you this equation right here with these reactants and these products, and they're asking how many moles of sodium fluoride will be produced if you start off with 3.5 moles of sodium that is reacted with excess, I believe it's sodium silicon hexafluoride, something like that. So first of all, you're going to check to see if your equation is balanced. Always do that as like a good habit before you even attempt the problem. And you might even get partial credit for showing a balanced equation. So I just go, for each element, I just go atom by atom to make sure everything is accounted for. So I have 2 sodiums and 4 sodiums here, so I get a total of 6. I have 1 silicon and I have 6 fluorines. Okay, let's see if that's true on this side. So I have 1 silicon, I have 6 sodiums, and I also have 6 fluorines. Let's double check. Fluorine and fluorine is 6, sodium and sodium is 6, and silicon are 1. So that's great. We confirm that it is balanced. And after you do that, you start with what they give you from the question stem. So they give you 3.5 moles of sodium to start off with. And we know that our goal is to get to moles of sodium fluoride. So given that we have balanced everything and we know what we're given and where we want to go, we can then set up our molar ratios. So we see here that for every 4 moles of sodium, we produce 6 moles of sodium fluoride. So we are given 3.5 moles of sodium. So we would expect to keep this ratio in balance, there's going to be slightly less sodium fluoride. That's also a good mental check later. Like if you're given less of your reactant, especially the limiting reactant in this case, you're going to have less product because you want this ratio, this 4-to-6 ratio to hold true. That's about 2-to-3, the ratio. Anyways, so going to our next step in the problem, we're going to use dimensional analysis to get the desired product. So again, we started off with 3.5 moles of sodium, and we saw here that for every 4 moles of sodium, we produce 6 moles of sodium fluoride. So set it up so that you end up with your desired product in the numerator. And the question stem was asking for 6 moles. So that's exactly why we're putting it up here in the numerator. And it makes it so that the units of what we're given and the ratio cancel out. So moles of sodium will yield us the exact amount of the moles of sodium fluoride. So I just did the multiplication and the division. And I found the answer to be 5.25 moles of sodium fluoride. And I left it in 3 sig figs because this is like the lowest amount of sig figs that was presented in the question stem. So if you're given this on an exam, you want to go with the sig figs that are the least amount. So 3.50 has 3 sig figs. So I'm going to leave my answer in 3 sig figs as well. And just something I wanted to point out, they might be trying to trip you up with this in excess that was in the beginning. And that might prompt you to think, oh no, I have to use this molar ratio in the equation. You don't, because they're asking just for, in the interest of sodium, how much of your product can you yield. If they were asking for both sodium and this sodium silicon hexafluoride, for example, I don't know if that's a proper name, then you would have to use both ratios, but they were just after sodium. So when I say in excess, all they're saying is that the quantity of the NiSiS6 was more than enough for the reaction to go through. So you're just going to look at the limiting reagent, and you can honestly, in a sense, ignore it because they're kind of giving it away with this in excess. They might be trying to trip you up, but yeah, just pay attention to what they're asking for. which was just in the interest of sodium, and you should be okay. See you in the next video.